All right, let's dive in. Today, we're going to pull back the curtain on one of the most incredible, invisible dances happening inside your body every single second: how you manage your blood sugar. It is a constant push and pull, a microscopic tug of war that keeps you fueled up and running. And it all starts with a really simple question. So think about it. You've just finished a great meal. Maybe some pasta, a sandwich, doesn't matter. You're feeling full, you're feeling good, but what is actually going on inside your bloodstream right now? Answering that one question is the key to understanding the two main characters in our story today. You see, it all comes down to a delicate balancing act. Your body is kind of obsessed with stability. It wants a steady state that scientists call homeostasis. It doesn't like things to be too high or too low. It wants everything to be just right. And when it comes to blood sugar or blood glucose, your body works tirelessly to keep it in a really, really narrow range. Now, this isn't just a casual preference. It's absolutely critical. Your cells, and let me tell you, especially your brain, need a constant, steady supply of glucose for energy just to function. So who's the command center for this whole operation? Well, that would be your pancreas. And even more specifically, these tiny little clusters of cells inside it called the islets of Langerhans. Now, if you look at this chart, you can see the breakdown, and there are two cell types that are the absolute stars of our show: the beta cells, making up about 75%, and the alpha cells, right around 20%. These two types of cells produce our two dueling hormones. I think it's easiest to think of them as a management team for your body's energy. Insulin, which comes from those beta cells, is our storage manager. After you eat, its job is to take all that new sugar and get it stored away for later. And on the flip side, you've got glucagon from the alpha cells. That's our warehouse foreman. Its job is to unlock that stored energy when your supplies start running low. You know, having these two opposing forces gives your body incredibly fine-tuned control. It's way more responsive than just having one signal to turn up or down. So if you remember just one thing from all of this, make it this right here. It's a simple antagonistic relationship. Insulin lowers your blood sugar, glucagon raises it. They are two sides of the exact same coin, always working against each other to keep you in that perfect balance. This is the core dynamic we're going to unpack. Okay, so let's walk through our first scenario. You've just eaten. The carbohydrates in your food are breaking down into glucose, and your blood sugar levels are starting to tick upwards. This is the signal. It's time for Team Insulin to spring into action. What happens next is a classic negative feedback loop. It's really elegant. The whole thing kicks off with that trigger, a rise in blood glucose. The beta cells in your pancreas detect this, and they're like, okay, go time, and they release insulin into your bloodstream. Insulin then acts like a messenger, telling your cells to start absorbing all that glucose. As the cells pull the sugar out of the blood, your blood glucose level falls. And once it's back in the normal range, the signal to release insulin just stops. It's a beautiful, self-regulating system. So what exactly is insulin telling your cells to do? Well, it's promoting what we call an anabolic state, which is just a fancy way of saying it's all about building and storing. First, it enables glucose uptake, basically opening the doors to your muscle and fat cells. Then it tells the liver to take any extra glucose and convert it into a storage molecule called glycogen. And on top of that, it encourages your body to store fat while actively blocking the breakdown of fat. You could say insulin is all about saving for a rainy day. Okay, let's fast forward a few hours. That meal is a distant memory. You've been working, moving around, and your cells have been using up all that available glucose. So naturally, your blood sugar levels start to dip. The energy stores are getting a little low, and it's time to call in the foreman. The main trigger for glucagon is the exact opposite of insulin's: low blood glucose, also known as hypoglycemia. When the alpha cells in your pancreas detect this dip, they release glucagon. Now, glucagon's main target is the liver, and its message is simple and direct: release the stored energy. The whole goal is to bring that blood sugar right back up into that healthy, normal range. This slide here shows us glucagon's core mission: promoting a catabolic state, which basically just means breaking things down for energy. First, it triggers glycogenolysis, which is the breakdown of that stored glycogen in the liver back into glucose. If that isn't enough, it kicks off gluconeogenesis. That's creating brand new glucose from other things like amino acids. It even promotes the breakdown of fat to get more raw materials for this process. Glucagon is the foreman throwing open the warehouse doors. So, we know what these hormones do, but how do they do it? Both insulin and glucagon are protein hormones, which means they're way too big to just waltz into a cell. They have to deliver their message from the outside through a kind of cellular handshake. Insulin's mechanism is like a master key. It binds to a specific receptor on the surface of a cell, which then activates an enzyme inside the cell. This sets off a chain reaction, a signal that tells these little vesicles full of glucose transporters, they're called GLUT4, to move to the cell's surface. Think of it like a bunch of new gates suddenly appearing on the cell wall, opening the way for glucose to just flood into the cell from the bloodstream. Glucagon uses a totally different, but just as clever, strategy. You can think of it like a megaphone. It binds to its receptor on a liver cell, which activates something called a G protein on the inside. This G protein then triggers the creation of what's called a second messenger. And this is where the magic happens. One single molecule of glucagon can create many molecules of this second messenger, which then just blasts the signal throughout the entire cell, activating all the enzymes needed to release a torrent of glucose. It's all about amplification.
Wow. So we've gone from the big picture all the way down to the tiny molecular level. But let's zoom back out and ask the most important question of all. Why does all of this incredibly complicated machinery matter so much?
Well, it all comes back to this number, this range right here. This is the target, the sweet spot for your blood glucose that this entire system, the pancreas, insulin, glucagon, the liver, all your cells, is working around the clock to maintain. 70 to 110 milligrams per deciliter.
And keeping your blood sugar in this range is absolutely non-negotiable. It's what ensures every part of your body has the fuel it needs to do its job. And get this, your brain, which is a massive consumer of glucose, doesn't even need insulin's key to let glucose in. It just completely relies on there being this steady, regulated supply in the blood at all times. This constant balancing act is literally what powers every thought, every movement, and every heartbeat.
When you think about it, this whole complex dance between storing and releasing energy happens constantly, perfectly, and completely without you ever having to think about it. It just works. It kind of makes you wonder, doesn't it? What other incredible, invisible systems are working tirelessly right this second just to keep you going?